So a star is really a balance between the enormous fusion explosion, which is creating all of that light and heat in the star, held together by the gravity of the star. So the star is extremely massive, and that mass holds that explosion together. And it's really just sitting there exploding for billions and billions of years. So while it's a pretty standard star, this is called... Yeah, we got some hands up here. Do you know what kind of star that one's called? The Sun. It's even bigger than the Sun. We got some other guesses here? Red giant, exactly. This is a red giant. So this is actually an old star. It's a bit cooler than our Sun, which is why it's kind of red. This star is extraordinarily massive. So if you put this star where our own Sun is, it would actually come out to the orbit of the planet Earth. So we would be on the edge of that star. It really is extremely massive. What about this star over here on this side? Does anybody want to know what this one might be? Does anyone have a guess? We've got a hand up over here. It does look kind of blue, but we call them a white dwarf. These are very small stars. And what we have here is a fairly unusual combination where we have these two stars orbiting each other. It doesn't happen all the time. Now remember that a star is a very careful balance between the explosion pushing everything outwards and the gravity holding everything in. Normally this balance is very stable, but if you have a situation like this, sometimes that balance can get upset. Oh. So let me just show you what happens. It's upset. So these two stars are orbiting each other. That the white dwarf starts very red giant. They get really close. And when it gets enough mass that it gets just bigger than just less than 1.5 times the mass of our own Sun, that balance gets really upset and the star explodes. And this is, of course, what we call a supernova. And it leaves behind this amazing nebula of all the stuff that was left over from the star. And these nebulae actually then go on to form actually all of the stuff that we're made out of and that the ship's made out of and everything in our solar system actually came from a supernova explosion like this. It all used to be in a star, it went supernova and formed a nebula, and then it went on to form all of us. So every single atom in your body has been through this process and released in a nebula. So that's pretty neat. What's really cool about this specific kind of supernova is because we know it happens when that white dwarf reaches exactly times the mass of our Sun. So we know, theoretically, how much light is produced in that explosion. So obviously, that's just a kind of visualization of what goes on. I'm going to show you the next movie. This is a bit more like what we actually see when we're observing in a telescope. So we've got the supernova galaxy like this. And we see over the period of about a month that the supernova gets brighter and brighter and brighter. After a couple of weeks, it reaches a peak brightness. And then over the next few weeks, it starts to decline. We call that the light curve. And that's pretty much what we actually see in galaxies. The brightness of the supernova is nearly as bright as all of the other billions of stars in the galaxy. And observe that brightness. So we go and follow up these galaxies, and we see, okay, that's the peak brightness. And then we know that that supernova exploded when it got to that mass. So with a bit of geometry, we can work out precisely how far away that supernova occurred. And then because we know the speed of light, we can work out how long that light took to reach us.